Welcome back to the deep dive. This is where we take your sources, the articles, the research, the notes you've shared, and we really dig in to find those key insights. The goal is basically to give you a shortcut to being well-informed, maybe with a few surprising facts, hopefully keeping you hooked.
Sounds good.
Today, we're diving deep into something we all experience, the weather. Specifically, these kind of invisible forces, pressure systems, and air masses.
Right. These huge blobs of air.
Exactly. And how they move and interact to create the conditions we see, day to day, sometimes predictable, sometimes not so much.
And the sources you've given us are great for this. They cover understanding those weather map lines, isobar charts, the different pressure systems, how air masses get their character, and then what happens when they bump into each other fronts.
Yeah.
There's even a really detailed look at a classic weather system, the polar front depression.
Okay.
So our mission really is to pull out the most important stuff from all this. We want to give you a clear picture of the basic building blocks of weather.
Right, so you can look at a forecast or even just the sky and get a sense of the why.
Exactly. Understand the mechanics behind it.
Okay. Think of it like getting the recipe for the weather, the raw ingredients, and how they mix. Right, let's get into it.
Let's do it.
Let's start with those maps then. Isobar charts. We see these lines everywhere. What exactly are they?
Okay, so they're pretty straightforward, actually. They're just lines connecting points that have the same atmospheric pressure.
Oh.
But critically, it's pressure calculated back down to mean sea level. So it gives you a level playing field, a picture of the pressure landscape.
And the sources use that analogy, comparing it to a terrain map, like contour lines.
That's a perfect analogy, yeah. Just like close contour lines meet a steep hill. Closely packed isobars mean the pressure is changing quickly over short distance. A steep pressure hill, if you like.
And this is where it gets interesting, right? Because that quick change, that steep gradient, that means strong wind.
Exactly. The air wants to flow from high to low pressure. And the steeper that gradient, the closer the lines, the faster it tries to go. Stronger wind.
Simple when you put it like that.
Yeah. And when we look at these isobar patterns, we see these main features pop out. You've got your lows, also called depressions or cyclones.
Okay.
And your highs, or anticyclones.
Yeah.
And then some other shapes, too, like troughs, ridges, and coals.
Right. Let's tackle the big ones first. Lows, depressions. What's the deal there?
So a low is basically a center of, well, lowest pressure, usually kind of roundish. The isobars show the pressure getting higher as you move away from that center. And the sources point out a deeper depression just means the pressure in the middle is even lower.
Okay.
Which means the isobars are packed tighter together and, stronger winds. They can vary a lot in size, too, from pretty small features to massive ones.
Thousands of miles, the sources said. Wow.
Yeah. Now, the physics bit. Air naturally wants to flow from high pressure towards low pressure. Simple enough. But the Earth's spinning. So the Coriolis force kicks in and deflects that moving air. In the Northern Hemisphere, it deflects it to the right.
Ah, the Coriolis effect.
Exactly. So instead of flowing straight in, the air ends up spiraling around the low pressure center. Anti-clockwise in the Northern Hemisphere.
Okay.
But crucially, it's still sort of angling inwards as it spirals.
Yeah.
So air is constantly piling up or converging right at the center of the low, near the surface.
Converging. So it's all coming together. Where does it go?
Up. It has nowhere else to go. It rises vertically right up through the atmosphere.
Okay. And rising air is key for weather, isn't it?
Absolutely fundamental for lows. As that air rises, it cools. And as it cools, any water vapor in it starts to condense into clouds.
Ah, cloud formation.
Yep. And this whole rising motion leads to unstable conditions in the atmosphere. The sources say this typically forms cumuliform clouds.
The puffy ones.
Those are the ones. Cumulus and the big rainmakers, cumulonimbus. So you get showers, often heavy rain.
Right.
And in extreme situations, particularly if you've got really warm, moist air feeding into it, that combination of rising air and the spinning motion can develop into tropical storms, hurricanes.
Cyclones.
Exactly, hence the name. And
all right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best